welcome to the subject software engineering. Now we are in chapter number 11 and today's topic is designing class-based components. We are continuing this topic since yesterday and today we will take up the later part of this topic, that is part 2. In this we will be discussing cohesion and coupling. So topic designing class-based components, and today's discussion will be on cohesion. Point number 1. In architectural design, that is a chapter number 9 that we have studied, we know cohesion as single-mindedness of a component. So single-mindedness means working on single component without bothering about other components. Point number 2. In the context of component level design for object-oriented systems, cohesion implies that a component or class encapsulates only attributes and operations that are closely related to one another and to the class or component itself. So students, when you think about the componental design in context of the object-oriented system, cohesion means that component or class encapsulates only attributes and operations that are related to one another or class or to that particular component itself. So types of cohesion. Types of cohesion are functional, layer and communicational. Whereas lower level of cohesion may be sequential, procedural, temporal or utility. So today we will discuss only in brief types of cohesion. So there are three types of cohesion. One is functional, another is layer, another is communicational. First we will take up functional. So this type of cohesion exhibited primarily by the operations. This level of cohesion occurs when a module performs one and only one computation and then returns the result. So in this case only one computation is performed and results are returned. Point number 2. Layer. Exhibited by packages, components and classes. This type of cohesion occurs when a higher layer accesses the services of a lower layer, but lower layers do not access higher layers. Point number 3. Communicational. All operations that access the same data are defined within one class. In general, such classes focus solely on the data in question, accessing and storing it. Note, in general, the higher the level of cohesion, the easier the component is to implement, test and maintain. So students, the cohesion level should be higher so that one can easily implement, test and maintain the components. Next we will take up coupling. Coupling, point number 1. Coupling is a qualitative measure of degree to which classes are connected to one another. So how two classes are connected to one another, that is defined by coupling. Point number 2. As the classes and components become more interdependent, coupling increases. So if there is more interdependency, that means there is more coupling. Point number 3. An important objective in component level design is to keep coupling as low as possible. So coupling should be as low as possible, whereas cohesion should be as high as possible. Coupling categories are 1. Content coupling, 2. Common coupling, 3. control coupling, fourth stamp coupling, fifth data coupling, sixth routine call coupling. So there are 6 categories of coupling, but main are first 2, content and common coupling. We will discuss today main, that is content coupling and common coupling. First, content coupling occurs when one component surreptitiously modifies data that is internal to another component, but this violates information hiding, a basic design concept. Students, you have studied what is information hiding. Information hiding means what? One type of information should not be made available to another or unauthorized access. But here in content coupling, occurs when one component surreptitiously modifies data that is internal to the other component. Point number 2. Common coupling occurs when number of components all make use of global variable. That means there are a number of components and there is a single global variable, and all the components make use of this global variable. Although this is sometimes necessary, common coupling can lead to uncontrolled error propagation and unforeseen side effects when changes are made. Students, when there is common coupling, that means what? All number of components make use of one common global variable. In such cases, if there is any error or side effects, that will propagate to other components also. So sometimes common coupling is bad. Software must communicate internally and externally. Therefore, coupling is a fact of life. Students, when there is communication, naturally there is interdependency, that means there is a coupling. However, the designer should work to reduce coupling wherever possible and understand ramification of high coupling when it cannot be avoided. Students, coupling, although is important concept, must be carefully used. So students, today we have learned cohesion and coupling and how it is related to designing class-based components. So today we will stop here and we will continue with the next topic in the next class. Thank you.